Look how to do some net ionic equation writing for some acids and bases. All right, so the first one that we're going to do is an example of a weak acid. Oh, wait a minute. I think I want to do the, let's see here, strong acid, strong base one first. So let's do that one first. All right, so a strong acid, strong base. So sulfuric acid. The formula for that is H2SO4. And we're assuming that it's aqueous, unless it says otherwise. Plus, let's say you mix that with a solution of sodium hydroxide. Now, you should know, I gave you a handout that tells you the strong acids that you need to memorize and the strong bases. Okay, and sulfuric acid is one of those acids that are strong. Well, when you mix an acid and a base, basically the H's go with the OH's to make water, and you get a salt. Okay, and so what's going to happen is we're going to get the salt, which is going to be sodium, which remember that's positive 1, and then sulfate is SO4 2 minus, so it's going to be Na2SO4 plus water. Now we got to balance that equation. Well, this we'll have to look up, but the water will be L for liquid. All right. And then we'll have to look up the sodium sulfate. Let's do that quick while we're waiting here. Okay, so the sodium and sulfate, if you look at that, that's aqueous here. All right. So then, let me see here. So then the sodium sulfate, it's aqueous, so we'll put an AQ there. Now let's balance this equation. So we'll go 2 sodiums there. And then now we got 2 H's and 2, that's 4 H's there, so we'll put a 2 there. We got 1 sulfate, we got 2 oxygens there, and 2 there. So that's balanced. Okay, now kind of the shortcut way, again, we could write everything out if we wanted to. But the way it goes is that anything that's aqueous on both sides of the equation will cancel. So the sodium is aqueous on this side, and it's aqueous on this side. The sulfate is aqueous on this side. The whole sulfate SO4 thing, it's also aqueous on this side. Okay, now what's not aqueous on both sides is the water, the hydrogen over here that makes up the water, and the oxygen here that makes up the water. So what we got to do is we have to rewrite this. Okay, so anyway, H2SO4 is really, you have 2 hydrogen ions, okay, plus a sulfate ion. That's really what H2SO4 is. Okay, so it's not hydrogen gas here, so it's not diatomic H2. So when you bring the H2 out to write the net ionic equation, you got to write 2H plus. Okay, and that's aqueous, plus 2OH, 2 hydroxides, negative. Okay, that's going to give 2 H2O, liquid. Now, we're almost done, except we have 2, 2, 2. That ionic equation should be reduced to the simplest whole number ratio. So it's going to be H plus OH negative, and that's going to give H2O. Now, most of the acid base, strong base, they're going to reduce to this H plus OH gives H2O. There's a couple of exceptions to that, and I'd like to show you one. Here's one right here. Okay, so sulfuric acid, once again, is H2SO4. We're going to say that that's aqueous, plus barium hydroxide. It's also, we're going to say, aqueous. Now what's going to happen is our salt will be barium sulfate, BaSO4. We'll have to look that one up. Plus H will go with the OH and make water, which we know that that's going to be L for liquid. Okay, so we'll look up the barium sulfate on our solubility table, and barium sulfate, and you can see that that forms a precipitate. Okay, so because that forms a precipitate, we have to not write aqueous there, but we have to put S in there for solid. Now, if you notice, when we look at this equation, we can't cancel anything out. But that doesn't mean we just write the equation exactly like it's written. So to put it in net ionic form, we have to break anything down that's a strong acid or strong base that's aqueous. So we're going to have two H pluses plus, that would be aqueous, plus a sulfate, and you know what? I don't know if I balanced the equation here, which I didn't, so we're going to have a 2 here. All right, but anyway, plus a sulfate, SO4 2 minus aqueous, plus a barium 2 positive aqueous, plus 2 hydroxides. Okay, because the net ionic equation is showing which things are ions in solution and which things are not. Okay, now that's going to make or yield barium sulfate, but it's going to be a precipitate. That's why we couldn't cross off the barium and the sulfate. Plus 2 molecules of water, or 2 moles of water, however you want to look at it. So anyway, make sure the equation balances. 4 hydrogens here, 4 hydrogens on that side, 2 oxygens there, 2 there, 1 sulfate there, 1 sulfate there, 1 barium there. Now, the charge should also balance. 2 positives plus 4, that's 4 positives, plus 2 negative here, plus 2 negative there, so that's going to cancel out to be 0. But this is the answer right here. This is kind of a complicated one there. All right, let's try another one here. Okay, so this one is a weak acid, strong base. All right, so we got acetic acid, which will be HC2H3O2 plus sodium hydroxide. So we're going to make our salt, which will be sodium acetate plus water. Okay, that equation's balanced. We know that the water is a liquid, and we're assuming that these things over here were aqueous. And this sodium acetate, if we look it up, you will see that it is aqueous, I'm pretty sure. Okay, so sodium, you can see most acetates are aqueous. Okay, so anyway, it is. All right, anyway, so we write sodium acetate as being aqueous right here. Okay, now anything that is a strong acid or strong base will dissociate, but weak bases, which this is weak, this is strong, weak bases don't dissociate hardly at all, so we don't break them apart into our ions. Unlike the strong acids or strong bases, we break them apart. Weak acids we leave together in a net ionic equation. Okay, so plus Na aqueous plus OH negative aqueous. That's going to give us over here the salt, an ionic compound. This is an ionic compound, so ionic compounds are said to dissociate pretty much all the way if they dissolve. Depends kind of how well it dissolves. But anyway, and then we have water here. Okay, so anything that is the same on each side, that's aqueous on each side, can be canceled out. It looks like sodium is a spectator ion, and I think that's it. Can't cross off the hydroxide, can't cross off the acetate ion. So we rewrite what's left over. HC2H3O2 aqueous plus hydroxide aqueous gives acetate aqueous, and I forgot to write the aqueous on this one up here, but okay, plus H2O liquid. Make sure everything balances on this side of the equation. Okay, so if you look, the atoms balance each other out. All right, but here's something interesting about the charge. On this side, the net charge is 0 and -1 here, and it's -1 and 0 here. So the charge also balances each other out. Okay, stay tuned. I'm going to do a strong acid, weak base, and a couple other examples in another video here in just 1 minute. I'll be working on that.